So I'm going to talk about my favorite babies because I've built it with one of my friends. His name is Babylon.js. So I've got a couple of demos. So my name is David. I'm working for Microsoft, and I'm part from the Microsoft Edge, you know, our new browser. So I know you don't like the new logo, but everybody wants my T-shirt, so I don't really understand what's going on. So I'm working mainly on web standard stuff as a program manager. So you can ping me on Twitter if you like to ask some question about WebGL, WebAudios, or Microsoft Edge in a general manner. So let's talk about Babylon.js. So we started building Babylon.js when we discovered that IE11 was about to support WebGL. So with a friend of mine, we really love 3Ds since we are little babies. So we started working on Amiga or Atari machines. I don't know if some of you have been using those machines, but we really love 3D since we are really young. And we decided to work our new frameworks on our spare time during the weekends and the nights, and then our wife really loved that, you know. And we start building it as an open source framework, and we put that on GitHub, so you can go on GitHub to download it. It's free. It's a Apache 2 license, so you add a reference to that, and you can start building the engine, because you probably know that WebGL and WebAudio is more easy to use, but WebGL is very difficult. You have to know about shaders, stuff like that. And we wanted to build a new framework that needs to be very easy for people to use. So let's have a couple of demos of what we've been doing. So I'm a Microsoft employee, so I'm using a PC. I don't know if you remember what a Windows PC is, but it's pretty cool also. So, and I'm using Visual Studio also. Well, I'm really a strange guy, I know. So we're going to launch the demos. So this is our website. So I've got some slight problem about the scaling, but it should be fine. Maybe I can change the resolution dynamically. Yes, if you don't mind. So let's change that to something different, just to let you see everything. I don't know what's the best resolution, so this should be something like that. Yeah, that should be better. Yes, should be better. So I'm going to launch this demo, so you can launch it on your favorite browser on your machine also, and you should have some sounds if everything works properly. And the idea is you have a 3D thing running in the browser, and I can switch the camera to the gamepad camera, so it supports the gamepad. You see, and I need to plug the gamepad properly, so you can talk. Well, it should work, but of course, this is my first failure, so let's do it again. I need to plug that on the proper USB port. I'm sorry for that. So this is a new Microsoft, but still the demo are failing, so. It's going to work. I've tested just before, so I'm pretty sure about that. Okay, let's do it again. Gamepad camera. It doesn't work. Okay, so the ID, I'm going to load it. We're supposed to have the support of the gamepad, so it will work on my machine. I can show you just after that. And I'm just going to go through the demos. So yeah, the idea is we're using WebGL and WebAudios for the 3D sounds. And I can move inside the scene using a mouse and keyboard. And when I'm moving near that, you can hear some frogs, because maybe you haven't noticed, but I am a French guy. That's why I've got a very strange accent. So we've got frogs in our scene, of course. And when I'm going to move near of Spatial, world, I can hear some pianos. So WebAudio is really handling that for me. I don't have to compute anything special. If I'm clicking through the glass and the windows, I can see a skeleton playing the pianos. That's why I can hear the sound. And we've got the symmetries over there. So we try to discover some of the things. So Hamlet is dead. for a moment. I don't know if you remember Clippy from our office. So it's dead also. And everybody is being asking the question, so is a Schrödinger cat dead or not? We really don't know. So to our mind, it's dead. And apparently we need to put a cat in every talk today, so we have a 3D cat. And finally, we're really happy to have been able to kill I6, and for killing it, we make fun of it, and we put like a Batman logo at the top of the castle. So the idea is we've been building that using 3D Studio Max, and this is one of our 3D artists that done that without using a single line of JavaScript code, and I'm going to explain you how we've done that. So to use it, if you are a JavaScript developer, well, you're going to create the engine, and then you're going to create a scene. So everything is scene graph. It means that you're going to create some kind of nodes you're going to attach to the scene, like creating a camera, for instance. We have various types of cameras, so I'm supposed to have a gamepad camera when it works, but the main one, the free camera, it's like an FPS one. You know, you're going to move the mouse and the keyboard, and then you're going to create some kind of lights, so you've got several types of lights, and then you will have some very simple, basic, what we call mesh. So for people that are not 3D gurus, mesh is simply 3D objects. And once you've done that, you're going to launch the loop. So the gaming loop, it's a render loop. It's going to use a regress animation frame under the hood. And then you put your game logic inside that. So as we've been working, this was our really first open source project with David, which was another David. I'm working with another David. And we discovered that even if you publish the code on the GitHub repo, nobody is going to read the code. And they're going to ping you on Twitter, on the forum, and then, can you please help me answering this question? Did you read the code? No, but you know, it's easy for you to answer that question. And so nobody reads the open source code. Apparently, I've discovered that as a Microsoft employee, so I really don't understand why for many years people said, please share the code. Well, if I'm sharing it, you don't read that. I don't see the purpose of that. So we were very worried about that, and we didn't want to spend all our time creating some documentation, because, you know, we are all developers. What we love is to create some code, and we don't love that much to document it. So we've been thinking about creating a playground. The idea is to let you play directly with the APIs. This is the beauty of the web, directly in your favorite browser, to test it. So let me show it to you. And I forgot to tell you also that we've been writing, first we've been writing it in pure JavaScript, then we rewrite everything. So it's funny to hear the previous talk, because we decided to rebuild everything from scratch using TypeScript for various reasons, because TypeScript helped us to find some bugs that were complex to find using pure JavaScript. And we were interested in compiling it in JavaScript, and then in the future in ECMAScript 6, so TypeScript support to be compiled to ECMAScript 6. So today we have various versions of our engine using that. So thanks to TypeScript also, we've got access to types. So we've been able to create this kind of playground. So the idea, you've got the line of code on the left and the immediate output on the right. So if you want, for instance, let's say, modify the color of the light, you're going to say light dot something, and then we're going to have a kind of auto-completion thanks to the TypeScript types that's being exposed. So I can say that I want to work on the diffuse color, and going to tell me, I don't know if you see it, that this is a specific type. The type of that is color free. So I know I need to create this type to put that inside the diffuse property. So now, let's say I'm going to say Babylon. So this is the name of our namespace, color free. Dot, we've got some predefined colors like purple. I like purple, I don't know why, but. And I'm not a 3D artist, so I'm going to build some awful stuff using some JavaScript code. So that's why you need a 3D artist to do some 3D. So you can change it like that, and you can play with the code. And the cool thing is that you can save it, and going to generate a specific URL. Then it's really helpful for us to debug the problem our user have, because most of the time, you know, they're going to say, well, your engine doesn't work. Yes, but can you explain it a little bit? When I'm using a light. Okay, with which kind of light? The point light. Okay, can you share a piece of code, please? So they're going to go on the playground, type it, repro it, it's going to send us the URL, then we're going to be able to say that this is not a bug from us, I'm really sorry. Sometimes we discovered some bugs in our code thanks to that. So it's really helpful to work with our users rather than creating a lot of documentation and exchanging all that. But we also have a good documentation. So this is the first part. So you can learn how to create some basic elements like that. You can learn how to use the light and do stuff like that. And we've got a shadow system. So we've got some more complex sample to let you play with it, modify it, fork it, do whatever you want, just to learn it in a very cool way. So this is for the engine itself. But if you want to learn what a shader is, so I don't know if what you know a shader is. So there was a previous talk about parallel computing that was really interesting. But in our case, what we're using, we have a lot of problems because of the mono-threaded problem of JavaScript. So we try to push a lot of stuff inside the GPU. So to talk with the GPU, you need to know what a shader is. So it's a specific language that looks like C, you can see there. So as a JavaScript developer, you're not maybe very used to that. So we've built this kind of playground again to let you play with that. So you've got the various type of shaders. So you can edit the shaders. So you got several ones. So I like this one. So pixel shader is going to act on the color of the pixel. So you can have the lighting system, you can have some transparency, you can have a lot of different effects. And the vertex shader is going to act on the geometries. That's why you see, you can see it's moving a little bit. And again, thanks to the power of the web, I can live edit my shaders and do whatever I want with it. For instance, let's say that I want to modify this value by 2.0 and rerun it. I can have some real-time output of that and start to learn how to play with the shaders. So the idea is normally you shouldn't be forced to use the shaders, but if you want to go further than just using the basic shaders engine we've got in our 3D engine, you can live edit them, test them, and inject it in your code. So once you've been able to work with some different primitives, so I'm going to show a demonstration of what you could do. So it's been using just some cubes and what we name a skybox. You can see that I am in the space currently. So I've been building this demo myself again, so it's why it's not very beautiful. So it's a maze, so it reminds me when I was playing Doom when I was young, or Wolfenstein 3Ds, you know. And the idea was to start from a QR code. I don't know if you've got some smartphones, so if you've got some smartphone, you can take them, and if you can flash some QR codes, because I'm currently moving inside a 3D QR code. So if you flash it, you will see that it's just said that Web Rebel really rocks. So you can edit what you want and transform it into a 3D QR code. So I don't know if it's really interesting for the web people to do that, but I spend a lot of hours building these demos. So. So now, let's say that you want to do something better than that. You need to work with some assets. So you need to work with, so the first export we've been doing is for Blender 3Ds. Blender is an open source and free tool, so it was the same philosophy we'd had with our engine. So we first decided to work with that. Then we had the opportunity to work with Ubisoft to write a kind of demos using Assassin's Creed, and they were using 3D Studio Max. They told us, you know, Blender is not a tool we're using frequently, so we've been doing an exporter for 3D Studio Max. That's worked really well, so you can see that. And finally, the last exporter we've been building is Unity 5. So I know that Unity 5 is being able to export some WebGL using ASM.js, so we can maybe talk about that later. But we decided also to just export the geometries. We've got our own format, which is also open source. It's a JSON format, so it's .Babylon. So you're going to take the 3D objects and dump it and all the texture to our formats, and then to be able to load it. So let me show you how it works. So you can take the free version of Unity, and you can, for instance, edit the scene like that. So there is a lot of free assets available on the Unity Asset Store, or you're working with your favorite 3D artist. Then you set your camera. Normally, it should look like that. And we've been building a plugin, so it's been written in C# because Unity is using C# with Mono. So you need to click on Export to Babylon, and it's going to create this thing. It's a new panel for our Babylon format to export it. So let's export it, for instance, on the desktop here, and I'm going to export it in this folder. It's going to then go through all the geometries of the mesh, take the textures, transform it into a web-compatible format. It's being done. And we want it, I wanted something very simple to test for the 3D designer, because the 3D designer are not at all web developers. So the simplest thing I've been able to find for them is just to take the output and to use the HTML5 drag and drop APIs to load it in the browser. So it's very simple for them to test it. They don't need to have a web server or stuff like that. And you can see that now I can move inside the 3D scene by doing nothing. So it's much better than my maze, I know, but this is because those guys are better to build some ships than I. So I've got, you can go further than that. I've got another scene. This one, a bit more complex. It took a bit more time to load. So I've already transformed that. So you can just copy-paste that again in the browser. And it works immediately, and I then can move in the 3D scenes. And of course, it works in all the browsers, so we are not stupid. We are aware that we don't have most of the market share today, so it works also inside all the browser. I need to do it another. I should shut my mouse before. Well, it works. You can test it. Once you export the scene, you need to load it using some piece of JavaScript code, okay? So to do that, I'm going to show you another piece of code. It's here. So what you need to do is to have an HTML page and have a couple of references. So the main one is Babylon.js to put some CSS. And the main stuff you need is just a 3D canvas to handle the WebGL stuff. To load our scene is very simple. It's just this line of code. So the idea is to load it using XHR request to the web server. It's going to load it. It's going to attach the control to the camera. The idea is to let you go through the scene using your mouse and keyboard. And that's pretty much it. You see, just 10 to 12 line of code to load a scene. And we're doing everything for you. We're building the shaders. We're building everything that you need to load the scenes. So we have a loading screens. Please. So we have a loading screens. And I can move inside the scene. I can go through the walls because we've got a collision systems. So we're doing everything for you. So it's quite simple to use. And let me prove that this is working inside Chrome, because this is working inside Chrome and Firefox and Opera and Safari. It's working on iPhones, Android devices. So you can go on www.babylon.js.com. I don't know if maybe Chrome got a problem, you know. Well, I will do it later. And the idea is, if you want to create your own camera, let's say, now that you want to switch to something using touch, for instance, you can create a new type of camera. So let's say you want to create something like virtual joystick camera for a smartphone or a touch screen. So you need to give it a name. Then you need to set a position. So I like to take the current active camera position and add it to the current scene. Now I need to set a couple of properties. I need to say that I want to check the collision, otherwise I will go through the wall. I need also to say that I want to apply the gravities, just to not to be able to fly. Then I need to say that I want to set the rotation property also, and to copy it from the active camera, so rotation. Okay. And now what I need to do is to replace the current active camera by this new one. and this should work. You see, it's just normally, the idea is to be able to replace any camera by using just one line of code. So, but this is a beta browser, you know. So it's going to load it. I'm doing some cleaning stuff in the meantime. And now I can move using my fingers, so my 2 fingers, my thumbs. So this is working in the same way on other browser. For that, we're using pointer events, and we know that pointer events is not being supported by all browsers, so we've been working on a polyfill library, which is open source also, named NGS. If you don't have pointer events, it's going to generate some touch event for other browsers. So it's the idea you write just using pointer events, we're going to propagate that on all browsers to be able to have this kind of experience. And it's very simple to replace. Let's say that now I want an Oculus camera instead. So I know it. I don't see the purpose of using Oculus on the web, but we have support for it. And you see, there's just one line of code, and normally it should switch to a double screen. So you need, of course, to have an Oculus device to have the rendering, but we're doing the thing for you. Just using one line of code, we're going to change the type of camera, and then if you're using an Oculus, we're going to use the input from it. And there is currently a standard being developed using VR, so we are supporting also that. We've got some contribution from the community on that. So we've got a couple of inputs. We've got touch, we've got device orientation. Virtual joystick is the one I've shown you. We've got an aglyph, we've got gamepad normally, and that's it. So now if you want to go further, thanks to the power of the current JavaScript engine, we've been able to add some physics stuff. So currently we're using an open source library named immersive.js. We've been trying also to improve the performance using the web worker. It's very difficult to optimize the performance using JavaScript because we are also stick to the UI thread. So even web workers sometimes, as we don't have yet shared memory in all browser, most of the time we are losing time by getting synchronized on the main thread. But we try to do some experiment, and it's already working well. So let's test just change the main stuff by using the physics version. And I'm going to relaunch that. It's going to load. You can discuss while it's loading. Don't be afraid. Okay, now, so if I'm pressing the S key, you see I can have a lot of ball that's going to bounce against all the walls, and I can have some boxes, and I can throw all the stuff. Normally it should be much faster, but I apparently have a problem on my machine currently, so I don't know what's going on, but should be much faster, so let's launch that inside. I know. I've got several browsers running some 3D scenes. Yes, much faster. Okay. Yes, better. So you see the new JavaScript engine, which is the Edge one, the IE one, the Chrome, Firefox version, now are being compiled in real time under the hood, and we have some native-like performance. The only problem we've had is if you have a lot of objects, it would be really great to have access to the multi-core CPUs to parallelize that. Currently, it's very difficult to do it, but still you can have some great experience using a single thread, you see. It's very impressive what the browser can do today using a simple JavaScript. So, as you've seen in the motion demo, we're using web audio also. So, I'm a bit old. I don't look old, apparently, but I'm a bit old, so I knew this kind of weird stuff, so the background sounds tag. Then we had Flash to improve the audios. Then the audio tag was not really as good as Flash. It was very difficult to do what you want to do. And today we have the most powerful audio stack ever. We've got web audios, so it's very, very powerful. There is some dark side about using web audios, but so Babylon.js today is based on web audios. It's very powerful, so we've got access to ambient sounds, to directional sounds, and of course we're using 3D sounds. It's very easy to use web audio, to be honest. It's very powerful. And you can create it using the Babylon.js APIs or load it from our format files. So that's why the 3D artist we've been working with, his name is Michel, has been using 3D Studio Max and just put the sound in specific place in the scene, export that in our format, and we load that. And you don't have to load anything using JavaScript. So today it can be exported from 3D Studio Max because Michel is using mainly 3D Studio Max. We need to update Blender and Unity to add support for audio. So let's do a couple of experiments I've been building. So again, let's go inside the playground. This is the easiest way to do it. So just to explain you, it's very difficult to understand how web audio is handling 3D. So what I've been doing is I've been creating some web audio sound that I've placed in the 3D scenes. And just to let you understand where they are, I've put some 3D sphere on top of it. So it's really to show you where they are currently. And I've been composing the music also, so I'm sorry if you don't like my music. So as soon as I'm going to move inside the sphere, I don't have to do any computation. This is done by web audio. You know where the listener is, so I'm just moving the listener, and you know where the 3D sound are. So as soon as I'm moving inside the first sphere, yes, we need sound. You can hear the music, and if I'm going close the center of the sphere, the sound is getting louder and louder. And if I'm moving outside the spheres, it's getting down. I don't have to do anything for that. This is web audio that's is currently handling that for me, and I can move inside other spheres. So this is to put your 3D sounds. This is very simple to set up. So once you've done that, maybe you will be interested in going a bit further, is to attach a sound to a mesh. So this is where we've been doing some code and to enhance this web audio in a way. The only thing you need to do is to create the Babylon.js sound that's going to create some web audio stuff. And then you see you need to attach to a specific mesh the music. Just doing that, our code will update everything for you, which means that if you take a headphone, you will hear the box going from the right to the left and in front of you and below you automatically. This is done by web audio again, and you don't have to do anything, there's just one line of code. Let me go back to the previous demonstration. What you can do also is to use real-time analysis. So for that, I've just wrapped some web audio code. So just to show you that you can do everything in the browser today. So I'm going to create an analyzer. It needs a scene. I need to connect it to the Babylon.js web audio engine. And finally, I've created a function on that. It's going to ask to draw a 2D canvas. That'd be over there. So when I'm moving inside the sphere, I can hear the sound and view it on the graph. So this is something that web audio is giving you. It's giving you access to the frequency in real time. So now you can take these frequencies, and you're not forced to do some 2D stuff. You can do other things. You can use, for instance, 3D stuff. You can take the same music and then create some 3D bars and to move it in real time thanks to the web audio frequencies that's being output. And mixing all that, this is one of my final demonstrations, so please help me to make it work. I'm doing some kind of praise the demo gods. So I've been using everything I've been explaining you, so web audios, I've been attaching a part of my music on every cube, so I've been splitting my music in 7 cubes, 7 tracks, attached to a cube. And when I'm going to move the cube near the center of the circle, we'll be able to hear it, and the sound would be louder and louder. So let's move it using my mouse. And you can see that I'm using also the same analyzer, but this time it's connected to particles, 3D particles. So the idea is to be able to mix the music doing that. It's very funny. And I like that because this is my music. And there is a stupid joke I can make. I can make the French version of my music by sticking the cube. And then you've got access to the French version of the music. And it supports also touch, because we are using pointer events, so I can mix it using several touch, like that. So using pointer events, and it's going to work also on other browsers thanks to our polyfill library, so it's very cool. So it's the kind of stuff you can build today in the browser. So I don't know if I've got 2 or 3 minutes left. Yes, good. I've got a very final demonstration, so it was if I had enough time. And we are not forced to use it to do its 3D stuff. So my idea was to create, I'm playing all the time with WebGL, Canvas, and I'm doing a lot of web conferences where people talk about accessibilities. And I'm personally involved in accessibilities for personal reasons. And while talking with one of my friends, I thought it was, well, this is very stupid. I'm spending my time building WebGL stuff that's not accessible. So I want to write an accessible game, but still I want something that interests all people. So I tried to create a breakout game being accessible for everybody. By using WebAudio and some experiment I've been doing, so I'm going to show it to you, and then I'm about to publish the source code on GitHub. So the idea is, when you start the game, by default, it's saying that you've got some problems, because maybe it's okay. So this is the current layout for people that are not blind but cannot see very well, so that's impaired. But if you're completely blind, well, we don't care. We can put something very beautiful. Because if you're playing with one of your friends that's not blind, you want to have a good visual output, so we're going to have some particles with that. I'm using SVG to be able to rescale everything, you see? And the beauty of SVG, I'm just putting some CSS stuff on top of my SVG element to transform it for the various problems that people may have. And let's first play the game if you don't have any problem. So very simple. We're using WebAudio, but in a very simple way. And I'm losing. So if I'm blind, I don't know where the ball is. I don't know if I've lost. So I need to find some audio output to help me. So I've been trying to create a gameplay with the blind people. So the idea, if now I'm activating the blind mode, is going to slow down the ball when it will go near the paddle, and is going also to provide some sound feedback to help the people to play the game. And it's going to speech also. So let's do it again.
Starting game.
You see the music is being slowed down when I'm far away from the paddle. So I know if it's playing the right speed, I am in front of the paddle. And if the ball is on the left, then the sound is only on the left.
Remaining.
Do you understand how it works? So if I'm closing my eyes, I should be able to play the game.
Remaining 11. Remaining.
Yeah, okay. So I've been testing it, and you can lose, of course.
Game
Even
over.
if you're blind, you can lose. And going to tell you that this is game over. So I'm using the speech using WebAudios, and I've been talking with some of my friends from Mozilla, told me that I could use a live ARIA section to improve that. So I'm about to finish the code and I'm going to publish. But just to show you that you can build a game that works for everybody, that blind people and non-blind people or visual impaired people, just by using WebAudio. WebAudio is just helping me to locate the sound on the right or on the left. And I can slow down the playback rate to tell to the user that currently the ball is not anymore in front of the paddle. So I've done a couple of experiments. If you're putting too much information, audio information, the blind people won't be able to really understand what's going on. So it's a bit difficult, but it was really interesting also to use my Babylon.js engine and to try to build an accessible game. So this was my last demonstration, and it worked. So if you got a question,
Wow, that was great. Please come over. We do have some questions for you. I'm quite happy that your demo started working because they were great. It was really interesting to see. So there's a few questions from here, but just on the first, was that last slide, was that links to your demos? Are they going to be available?
yes, there is I can show it to you. You can have access to the main site, Babylon.js.com, the playground to create some shadows, and we've got the forum when we try to answer to any of your questions if the docs or the sample are not enough. And I will publish, most of the demos I've been showing you are available either here or on my own blog. So
yeah. So these are all kind of smaller demos and fun things. Is there something serious built with this yet?
So we've been working with Ubisoft, create a game. We've got a couple of projects inside Microsoft that are using it. The fun thing is that sometimes Microsoft people are trying to build some new product using web technologies, and they're benchmarking it. So maybe you know also 3GS or the libraries. So sometimes they're benchmarking it. And choose Babylon.js, and then they discover that this is written by Microsoft employee. Mm-hmm. So they contact us. Well, you're from Microsoft. You see that because it's open source and free, they don't realize this is from Microsoft people. And say, how many people are in the team? Say we are two. Yes, because I'm working with something that I'm not sure that the other David is living. I think he's coming from another planet really, because he has been able to create most of the engine inside a complete weekend. Because this is his fifth 3D engine, and he's coding 3D things is, I think, 2 or 3, you know. So it's quite crazy. So we've got some internal project. I'm not allowed to disclose them yet, but it's going
to be... Give us a hint.
Yes, it's going to be very cool.
Let's go. Oh, okay. Well, I think we kind of worked that one out. So there was a bit of clapping during your talk, and I love the fact that we all did more clapping for the death of Clippy than the death of IE6. I thought IE6 was sure to be like the thing to be celebrated. But there are some things, obviously, from Microsoft past that actually have become nostalgic. And one of them is the pipes screensaver. Have you thought about recreating the pipes screensaver with Babylon.js?
It should be quite easy to do it, yes. If you really think that we could have a business on that, I've got to think about that. But if
I'm not sure you can make a business out of it, but I think a few people would appreciate that. That's good. There's this question about, can you use Oimo.js with 3JS as well?
Yes, if you go on the Oimo.js site, most of the demos are built on top of 3JS. So it's really not linked, so you can use any 3D engine you want to. And what we've done is just a kind of proxy between our engine and any physics engines, because we spent a lot of time working on the 3D and audio part, and we didn't want to spend some time on the physics engine, which is quite complex. So we've got a plugin mechanisms that you can load any open source physics engine. And what we're doing is just to do the connection between the way the physics engine works and our own 3D engine works. But you have a couple of demonstrations using 3JS. But if I were you, I would use rather Babylon.js.
Well, of course, that's clear. But we did see some problems with performance here. What are your thoughts around that?
The main problem with performance today that, well, this is my machine probably had a problem today, but we have no problem being able to have 16 frames per second on a small GPU. This is a very small GPU, so this is an Intel one. This is not an NVIDIA dedicated. And I'm forcing myself to use this machine because it's not very powerful. And I know if I'm being able to optimize my code on a small machine, it will run everywhere properly. Because if you're running it on a big NVIDIA GPU on your desktop machine, and then you push that on the, let's say, on an iPhone or Android device, it won't work the same way. So this is more or less as powerful as an iPhone, this machine. So it's very interesting to debug on it and to optimize performance on that. But people are most of the time amazed by the performance. If you put that in full screen with a gamepad, nobody will know that this is HTML5. And most of the users don't care about is it HTML5 or native code. Just want to have some fun with the games. So where do you think we'll see this next? Like, you talked a little bit about this thing you're doing with Ubisoft and the internal Microsoft project. So currently we are trying to work also on on Unity, because Unity, it was interesting that Unity have got a WebGL exporter, but today when they export them, they use SMGS, and the JavaScript code being generated cannot be maintained, and you're loading a lot of JavaScript code just to display sometimes very few objects. So they were interesting in our exporter, so we're currently in relationship with some of them to improve that and have access to where they're working. And also we want to optimize the performance, so we're currently trying to use SimD.js inside Babylon.js. We've been able to improve a lot the performance on that. And for the Microsoft projects, I guess it will normally ship by the end of the year, so to display some 3D contents. We've got some companies in France, so I'm French, so I know a lot of French people, that buildings when they're building some new, let's say, buildings, real buildings, they're creating using models with their engines to help them doing the pre-sale stuff. Yeah. So for their business, for B2B business, they're being able to use it. And the problem is we are not forcing people to communicate that they're using our engine. We know that there are a lot of projects, but if people don't say that to us, we don't know where they are. So we only know the public project that people share on the forums or on Twitter.
So finally, just at the end, you were showing us a little bit about how you can use the web audio to enhance accessibility. Do you see that? Where do you see that going? Well, do you see more places that we can use that?
Yes. The problem when you talk about accessibility, most of the time in the web project, it came at the end. So people say, well, my project is not accessible, and that it's too late to modify that. And in the video game, this is even worse because nobody cares about accessibilities. And the idea was to have a kind of universal design. This is what I try to do, is to think about integrating everybody indirectly in the UI, in the gameplay at the beginning. And this is what the web is about since the beginning, is to be accessible to everybody. And the problem about WebGL stuff, it's only accessible to people that can see. So I think that if we force ourselves with any technologies to think about how could I integrate people that are visually impaired or cannot hear using other stuff, it could be very interesting. So I had other ideas to be able to access to the vibration APIs on the gamepad.
Yeah.
But today you cannot mix. The vibration APIs are only available, I think, on Firefox OS, and it's only for phones. So it would be great, for instance, to have access to that on gamepad, because I can give some other type of feedbacks to the user if I can vibrate the gamepad, if, for instance, the ball was on the left, or if the pad is not aligned anymore. You can really think about all these new APIs to improve also the experience for those people. So this was more or less my serious message of the conference.
Yeah, no, and that's something I've been sort of interested in personally as well, so that really resonates with me.
Okay.
And I hope with more people out here will take that message to heart, because I think it's really important.
Thank you.
And it makes it more fun for everyone to play, right? If you have good sound, or if you have good visuals, if you have good feedback.
And you know the fun thing about that story, the first time I've been testing it with the blind people, she was a bit surprised, and she never knew about what a breakout game was. And I was feeling a bit stupid. I was telling her, well, this is a breakout game. And she told me, what a breakout game is. Yeah, of course, you don't know what the breakout is. So we got bricks and go to break them using a ball. Okay. And this is a fun game. It's supposed to be, yeah, so. And then I've tried to improve the gameplay with her. And at the end of the game, I was telling her, so you need to break all bricks, and you will have the score based on the time it took to break all them. And she told me, what's the best score? I want to be the best score. And I was so proud because she wanted to play more the game. And we decided with another web conferences, it could be very fun to use, for instance, WebSockets or stuff like that, to have some kind of competition of blind people versus non-blind people, and to check who will be the best one. And it would be awesome to do that.
That'd be fun. I'd love to see that. Thank you so much, David.
Thank you.